Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today I am so happy to say we have Omicron Lab in the lab. And really cool box. I'm going to show you all what comes in this box in another video. I should have started with a video like that, right? An unboxing video, kind of like, hey, what is this thing? Well, Omicron sent me this Bode 100, and they've given it to me. I kind of paused there for a moment. They're going to give it to me if I use it in videos. And I'm going to use it in videos. I've got a lot of videos planned for this. It's been staring at me in the face for a while now, and I've been just dying to use it. So I broke it out, okay? And we're going to use it on this Class D Amplifier. It's an expensive board over here. It's over $500 for this single channel. I got two channels. They're over $1,000 for the two boards. So I thought, perfect time to break out the Bode 100 box. And that's what this thing is. Okay, it's about a foot deep, I'd say, and you can see how narrow it is. And I've got it sitting up on its side. All right. So what does this thing do? What this does is it does Bode plots, just like my scope can. My GW Insta can do Bode plots. You've seen me do it on this board. But one thing with the Bode plot and also the FFT, this thing's limited to 8 bits, right? Now, you've seen me show the Pico scope that has 12 up to 14 bits resolution, it's a huge resolution benefit to have that many bits, vertical resolution, instead of only 8 bits, so it's just awesome to be able to do that. Well, when I'm doing Bode plots, I'm also, even though it's not as obvious because you're not seeing all the little spikes you do in FFT, and you have this noise floor, is it 40 dB or 60 dB or is it 100 dB? Well, you can't get 100 dB on 8 bits, okay? With my Pico, now we're talking, okay? Well, with my Pico, if I could do Bode plots, well then, do I need this? Well, let me explain some of the benefits of what this thing does. This guy's 24 bits, so it just blows away the resolution question. You don't have to worry about it. You got so much resolution, it's ridiculous. It's no longer even a factor. So whatever volts you're measuring on this, yeah, you can believe it. There's not very many instruments in your lab and in a lab that you're going to get better resolution. 24 bits is awesome. So that's out of the question. Okay, as far as what it'll do, well, you can do simple Bode plots. I'm going to show you one today. That's what we're going to do today, okay? I'm going to show you the software, show you how cool it looks and how neat it is and how easy it is to set up versus going through a whole bunch of things on, like, say, a scope or something. You pull up the software panel, very nice, you'll see, okay? So I'll bring the camera over for that. But you know what, guys? The other thing with these things is the first time I've ever used a box like this, it was called a Venable box. And I think he's the one that kind of came up with the whole idea, the whole concept of, hey, we got a power supply. We don't want to go unstable. We want to look at that feedback loop. We want to make sure the open loop, the closed loop response is good. And so they came up with these techniques and power supplies on how you could do that. When you use a scope or spectrum or other equipment to do that, it's pretty tedious, and honestly, you have to be a pretty good engineer to figure out how to do it. You won't see these kind of instruments on too many benches. You just won't. They're specialized equipment. They're not inexpensive. This thing's, I'll look at the dollars, but I believe it's over 5,000 US. So thank you, Omicron. It's one of the most expensive pieces of equipment I have in the lab. And you know, it's funny. Just by the way, this is an English company, and Pico scope, also English. Man, the English have been very good to me. That's awesome. I don't know why, but the English seem to like me. So, you know, Hioki's been awesome. I got a Hioki hat. I don't know if you can see that. I got that sitting over here. So, yeah, I've had some other companies. You know, Kaiwit's been great. There's been a few others, but U.S. companies, yeah, I don't think there's many U.S. companies that's kind of helped me out. But Omicron, they've done what the Bode box did for the Venable equipment I used years ago, but they've just stepped it up like to a whole nother playing field. Okay, very easy to use, very simple. The old Venable box, I've used some software in that not that long ago, and it's still kind of old school. And yeah, and there's some other people that have come out with boxes. Dr. Ray Ridley has a box of his that he kind of, you know, took a notch up from Venable. But this guy here, I gotta say, I think it's just a level above them all. I don't, you know, maybe you guys are gonna argue with me, I don't know, but right now, I'm gonna tell you that I'm gonna show you a couple pieces that I'm gonna show you today. This guy right here, the generator, I have 3 connections on this, on the front. On the back, I've got a USB that goes to my computer and a input for power. Okay. On the front, I've got this output. It's a signal output. This guy right here, this really nicely made little blue box. This is an isolation transformer. So it takes my, you know, and these 2 probes actually are not what I got with it, but they are differential probes. So I'm completely isolated from the Class D amp. Okay, this guy here, like I said, 1-to-1 and turns ratio, so just gives me galvanic isolation from input to output. But you know what's really neat about this thing is it goes from 1 hertz to 10 megahertz. That is very impressive. That's a huge bandwidth. Other systems, you'll have several boxes. So if you're at this frequency range, use this box. You're this frequency range, you know. And then if you want to get a box that's similar to this, that's wideband, it's an active box, it costs you $1,000 or $2,000. So when you look at what I got with this, and I'll show you all that stuff in another video, it's actually pretty darn impressive for what it does. And I'm going to show this thing doing power supply, you know, analysis and that. Okay, so besides showing the gain and phase of an amplifier or the feedback system, you know, the gain system of a power supply, it can also do input and output impedance. So those things are very important. We're going to talk about that kind of stuff, Middlebrook criterion, things like that. We're going to talk about those kind of things in videos to come. But this thing will do those things. And that's, like I say, those are very crucial and important things to know about when you're designing filters that hook up to power supplies, or power supplies that are going to power another power supply. When you have things gained together, you need to know those input and output impedances to make sure the compatibility is okay. Now, the other thing is filters. So even for speaker filters, for audio systems, for EMI systems, this thing will, or just components themselves. Yeah, you can do a lot of that stuff. Like I say, you can do that stuff on your scopes, but 24 bits and blah, blah, blah. I mean, this guy here is just going to give you really great results. So let's come over here and do the phase gain of this guy here just to see what it looks like. I just want to show you the software, okay? Let's just go ahead and do that. And thank you, Omicron Labs. I can't believe it. I can't believe I got one of these on the bench, and I'm going to make a place for it on the bench that we'll use this thing in a lot of places. And I'll show you how to do it in other ways too. But yeah, well, you know, I always want to show how you can do things without spending a lot of money. But we got this guy now, so we'll also show what the professional guys, you can't get any better, okay? So we can see what the high end is like compared to what we could do by, I don't want to say kludging, by doing it in other ways, okay? And we'll see the difference. You know, for most of us, the difference might not be, hey, we're fine with it. But, you know, for guys who have the money to have build up a lab that want to do things and not have any concerns about the measurements, then, yeah, this guy might be the one. All right, let's come over and do a sweep and take a look at the software, okay? Alright guys, so now the software comes up in this configuration, and you can see the 3 tabs over here. Over on the left you can see some recent things that I've pulled up and looked at, and you can see a user's manual. It's really nice. All that stuff comes up really fast and easy. You got impedance analysis on this tab. You can see all these different tests you have right down here, right? So if I close these guys, you know, you got all these different things you can do, okay? And then you have an advanced tab. We're going to come over here and go to the gain phase. So we're going to hit this one, and it just takes a moment. There we go. And look at that nice window. Alright, so now the view, I could probably come in here and change my screen. I haven't tried to do any of that. I'm really new at this software right now. Okay, so let me just show you what I know we can do. Over here on the left, you can set up your frequency. 10 hertz, let's start there. And let's go to, or I don't know, let's go 500 kilohertz. Let's just go way out there so we can see all that stuff we did before on the GWN stick. Okay, so then there's the information there. We're going to do logarithmic, number of points 201. Look at that. We can select a whole bunch more if we want, but I think 201 will give us a nice picture. Okay, and our signal. You know what? I'm going to put in a couple watts probably. Yeah, let's do a couple watts. So it'd be about minus 6 dBm. And receiver bandwidth, you know what? Look at all these bandwidths I have. I can, you know what? I'll just go to 100 hertz maybe. That should be pretty good. And you know what I'm going to do? You know what? Actually, I think I'm going to go to a little higher bandwidth. I want to select 10. That's pretty high. Now, when I hit this continues. It'll continue running the plot over and over across these frequencies. I want to just do a single. See, once I hover over one of these things, it gives me an explanation of what that is. Configuration of your hardware. So let's do that. Okay, now on channel probe 1, I actually have a 20x differential. Probe 2, I have a 100x. Okay, so this is our setup. We're going to do our input. It's our output of our generator from the Bode, and it's going to run through our signal or device under test. That's what that means. And so this will be the input to our amplifier, and this will be the output of our amplifier. And then so we have our 2 receivers, and yeah, I think we're set up, ready to go. So I believe, yeah, that looks good. Auto off, so as soon as it gets done with the sweep, it just turns itself off. And our source level is there. So see, we can set up some of the same stuff we could have done over here. But okay, let's go ahead and close that. Here's our screen here in the middle. Minus 100 dB, plus 20. I want to go a little bit higher so I can see a little bit more. And I don't think I need to go down to 100. So we'll go to 80 maybe. And we can always change this after the measurement, I believe. Trace 2 is going to be blue, and it's our phase. Trace 1 is our magnitude. Okay, so I think we're set. I'll just leave the 200 minus 200 degrees. I'm going to leave the phase where it is, even though it's going to be fairly flat. Right here at the end, it does some funny stuff. So let's go ahead and do that. Now you're going to hear my power supplies turn on. Okay, put my protective stuff on. Okay, here we go. Let's turn on the power. Power supplies are cranking. You probably can hear those. I'll turn on my plus minus 18 volt. That's from input circuitry. Crank up the output voltage rails to plus minus 31.6. That's max on this particular power supply. Okay, then I'll bring up my voltage, 15 volts for the low side driver on this Class D amp. Okay, I think we're ready to go. Let's do it. And you'll start seeing a sweep. Look, we're up here at 25 dBs. And the phase is right here. See over here, it's 0. So we're, yeah, I mean, it's really flat. And look how flat this gain is. Super flat. Now we could zoom in on that gain so we could see how flat it is. But down here, when it goes past 20K, from what I remember on the GWN stack, it you know, kind of had a rise in gain and then it dropped. So actually I might even increase this gain just to 40. So, or maybe I'll go to 60. I forget how high it rises. There you go. It's taken off. And then it drops down. All right. So I guess I could drop that back down to 40. And you see the phase. That's why I left the phase the way I did. Because it really shoots down. And really this is a continuation down here. But it just pops up here and continues down this way. So instead of dropping off the screen, it just drops up here and brings it down. Okay? Imagine taking the top part of this paper for phase and the bottom part of the paper and connecting them. And this just circles around it. Okay? So anyway, there you go. And here's our connections down here in the lower left corner. So what do you guys think? That's pretty cool, huh? Pretty easy. And you know, you can count on the voltage resolution here because of the awesome 24-bit resolution. Now that we've scanned this, let me turn off my power supply so make it a little less noisy. All right, that sounds a little better. Now, see this part right here? I can zoom in on this if I just go down to, say, okay, let's say we go to 30 and then we bring this, stretch this up. Now I can just type it in here too. I'll just type in 22 dBs and actually make this guy 26 dBs. So it looked like right through here it did have a little bit of a little teeny thing. This is 25.2. So you see what I'm talking about? The resolution is we can see down to fractions of a dB. Now this is fractions of a dB, guys. Now I can make that look even worse by going to, say, 24.5 on the bottom and zooming in this to, say, 25.5. And you see what I mean? I mean, look at the resolution. See how even this is. Now, when you go with points, you grab more points, you can get more resolution. And maybe, you know, maybe I could do that. Maybe I could go from 10 to 1K. You know what? Let's just do that. Just to be fair here. Let's see if that's actually there. See what really is there. And we'll go more points just to try to zero in on this, okay? Let's do that plot just through that section. Oops, I got to turn on my power supplies, guys. Got a little ahead of myself, didn't I? All right, plus minus 18's applied. Plus minus 31.6. And now my 15-volt driver's on. So now we're ready to do it. I'll keep my cursor up here in case I have to hit stop real quick for some reason, which I'm sure I won't, but it's always good to have your finger close to the power button. Now, I'm grabbing 800 points. That's why this thing's slowed down. That's why you don't want to really grab more points than you need to get the resolution you want. Now that red one is the voltage. Now look how, since we're zoomed in from 24.5 to 25, that's 1 dB of resolution, guys, from top to bottom of this screen. So that little wiggle there is minute. And that's what you can see with a 24 dB analog to digital front end. And you can see how just flush the phase is. Because right over here is 0. And through this range right here, we're not going to see much. So I can actually zoom in on the phase just to see what's going on there, guys. You never know, right? Let's go to 10 and minus 10. I'll just type it in this time. All right, so now you can see, look, this is 20 degrees phase margin through here. So we are zoomed in so close, and there's that stuff. Now look, now that we got more points, there is a little bit of funniness that goes on between 20, 30, 40, around 50 hertz. Maybe that's a little bit of power supply 60 hertz noise coming in. I don't know, because it's hitting right about 60 hertz, right? Yeah, I almost wonder if there's just a teeny bit of 60 hertz, but guys, we're talking a teeny bit. Those peaks are 25.15, so it's 0.15 dB. I mean, the resolution is ridiculous. So there's the value of a Bode 100 box. Alright guys, there we go. So out here at 1K, it dropped that much, almost 1 degree, not even 1 degree, 3/4 of a degree. So yeah, we're really zeroed in, and that's pretty crazy. Now this power supply noise, by the way, is probably 60 hertz noise coming in through our system, and then that'd be about 120 hertz. So that's I hit my mouse pad, I guess, and wow, there's some optimization. There's a lot of cool features I need to learn how to use. And one is to do an undo when I change my zoom. There we go, reset zoom. Yeah, I did something screwy there. So yeah, this power supply noise, by the way, what I was talking about, the 60 hertz, this looks like a harmonic here at 120. Because this is 200 hertz here. That is pretty darn cool that only that much comes through. I have 3 different power supplies powering this board. One of them has just a teeny bit of 60 hertz, but the power supply rejection of this amplifier is rejecting most of it, but that much snuck through. So that is a pretty cool thing. Let's go to 20K. Let's just see how flat this thing is all the way up to 20K, guys. This could be fun. Still have the power supplies running, so why not? Now this resolution is going to be kind of nuts. So let's go to 400. Let's see if we can speed that up a little bit. I guess I have to start over when I change that. I think 400 is still going to be pretty darn tight. Okay, I'm going to keep my mouth shut, and then I'll speed through this in the video. Alright guys, so that is pretty darn impressive, right? And I'm going to have to learn how to use the cursors and all that kind of stuff. Haven't played with this thing long enough to learn any of this stuff. I know I can come up here and type in cursor information, like I can just type in a frequency and it'll drop a cursor right there. See that cursor? And then I guess I can grab it once it's in the screen and look at the XY cursors. So I could go down to, this one's attached to the phase right there, and we can kind of see what's happening there. That's at 6.7 kilohertz. There's a little bit of a notch there, but you know what? I want to remind you that we're zoomed in. It's only 1 decibel between these lines. So this thing dropped from 25.02 or something down to 24.75. So it's dropping about a quarter of a dB, you know, right through here, right? So if I just increase this to say 30 and drop that to 20, see how flat that looks? And you know, you don't really even zoom in that close normally. And the degrees, I mean the phase, See the phase drop down -10 degrees. So, I mean, that is pretty darn good, guys. Pretty flat. But you can see the power of the Omicron Lab device. That's what I wanted to show you, just as a first introduction to using this piece of equipment. And I hope that was interesting. All right, there's my protective cover. So, what do you guys think of that? I mean, the power of Omicron Lab in the lab. Pretty darn cool. The software suite is super easy. Excited. You know, I was really excited. I just wanted to kind of show, demonstrate, you know, what it can do for how little I've used it. I've only played with it for just today, just playing around a little bit. Just opened up the software. It looked super simple, and did a couple sweeps and thought, heck, let's do a video. But I'm gonna learn how to use this. It looks like there's a lot of power in it, and it looks very intuitive. So I think it will be. The learning curve is gonna be short on this thing. But there's so many different things we can do on this. I'm gonna do some filters, crossovers, and I'm going to do some power supply stuff. I can't wait to do the power supply stuff. I've got a power supply right now. I can't wait to get on the bench. I've been testing this audio amp, so I thought this would be a good time to demonstrate the value of the resolution that you can get with an Omicron Labs, and why this guy, if you're doing really serious stuff and you really need something like this, then there you go. There's not a lot of competitors in the field, and from the ones I've used, or you know, in the past, I've used a couple of them, and there's only a couple others, I think. Well, there's another one I haven't had my hands on yet, but anyway, this one here, it's the simplest to use that by far from some of the other ones I've used, and I'm really happy with it. Thank you, Omicron Labs. I hope to make you guys happy with sending this to me. We're going to use it, and let me know what you guys think. I want to thank my Patreons, all the companies that support the channel, and I mean, they support the channel by giving me things. I never get paid for anything. No one ever tells me what to say on these videos. They sent this to me, said, hey, use it in some videos. If you do, you can have it. If not, send it back to us. That's it. You know, oh, and let us know when you post a video. That's it. So, and that's the way all the companies have been. I had one company that wanted to see a video first, and I said, no, I mean, it's a $20 meter. I'm like, no, I'll just send the meter back. And they said, forget it. Just post a video. We trust you. And ever since then, it's been that way. So, yeah, I'm very happy to get this equipment for free. Very happy about that. But I haven't been sponsored in a way where I'm paid to do a channel. And even if I was paid to do something, I still would be honest with you guys. And that would be the reason they'd want to sponsor me in the first place, is because otherwise everybody would know that you're not being honest, and then no one's going to watch, and what good's that? That doesn't do anybody any good. So I'm just excited to use this stuff, and I've got a lot of work to do that I can see this thing coming in handy. I can't wait to use it. So, and like I said, I'm going to use the scopes and the other ways to do the same thing. Maybe just not with the same resolution, but we can see the difference. And like, it's ridiculous the resolution you can see on this, right? Do you need that? A lot of us would probably say no, but if you do need it, there you go. All right, guys, thanks a lot. Hope you like this. I talked a lot. Sorry about that, but I was excited. All right, hey, we'll see you next time.